Hey, so let's dive right in. Today, we're taking a look at the very foundations of physics. We're going to explore a really provocative idea, the idea that for centuries, we might have been missing the most important part of the story when it comes to understanding our universe. I mean, think about it. What if all those beautiful, elegant equations we use to map out reality, from the Big Bang all the way to today, what if they're only telling us what happens and completely leaving out the crucial part, how it happens? So this is the core idea from the material we're looking at today. It's a really bold proposal, right? It says physics needs a new fundamental rule. It's not enough anymore to just describe something happening. You have to first show the actual physical machinery that makes it go. Okay, so to really get why this idea is so radical, let's first take a quick look at how physics usually works right now. A huge part of modern physics is all about finding these beautiful mathematical patterns, these symmetries, and really powerful, simple formulas. Things like differential equations that predict how stuff changes over time. They're incredibly useful tools for sure, but are they the whole picture? This slide really just nails the central conflict. On one side, you've got the description, the formulas, the probabilities, the stuff that tells us what to expect. But on the other side, there's the machinery, the actual gears, the physical mechanism, the real cause. The answer to the question, what is this thing literally made of? The argument here is that we've gotten so good at the what that we've kind of forgotten to demand an answer for the how. And according to our source, this focus on just describing things has led to some real problems. We end up using concepts that aren't really defined in a physical sense, and we lean on probabilities that are fantastic at predicting what's going to happen, but they don't explain why it happens. That deeper explanation, the why and the how, just isn't there. Now, I know this all might sound a little abstract, so let's make it super concrete. We're going to look at three huge ideas in cosmology where, if you follow this critique, the machinery is totally missing in action. All right, first up, cosmic inflation. This is a massive part of the Big Bang theory. It's the idea that the universe went through this insane exponential expansion just moments after it all began. And look, it's a theory that solves a ton of puzzles in our models. But here it is, the big question this new rule makes us ask. It's awesome that the math checks out, but what was the physical thing? What was the actual machinery that was making space itself blow up at that unbelievable speed? You see, the theory describes that it happened, and the equations show how it could work, but the source argues it just doesn't give us the complete machinery. What was the tangible force doing the pushing? Why was it exponential? The how is just gone. Okay, let's move to our second example, and this one makes the problem even more obvious: dark energy. This is just the name we've given to whatever is causing the universe's expansion to speed up right now. It is genuinely one of the biggest mysteries in all of science. And you guessed it, we have to ask, what even is it? Sure, we can stick a symbol for it in our equations, and that symbol makes our formulas match what we see. But what does that symbol actually represent in the real world? Basically, just calling something dark energy and giving it a symbol doesn't explain what it is physically. It's a placeholder. It's a label on an empty box. We can see the effect it has, but we have absolutely no idea what the cause, the substance, the actual machinery is. And that brings us to our last example, dark matter. Its effects are everywhere. We see galaxies spinning way too fast to hold themselves together, and huge galaxy clusters that should be flying apart, but they aren't. So we figure there has to be some invisible mass, some dark matter, giving it all that extra gravity. You know the question by now, right? We see the gravitational effects, but what is the machinery creating those effects? For decades, the most popular idea has been some new kind of particle we just haven't found yet. But here's the thing. After all this time and after building these massive, incredibly sensitive experiments, we found nothing. Zero. And this is a perfect example of the source's point. When you propose a specific machine, like a new particle, and you keep looking for it and come up empty again and again, maybe it's time to question the whole idea and look for a totally different explanation. So, we've pointed out some pretty big gaps in our understanding. What's the fix? Well, that brings us to the core proposal of this whole thing. It's a new rule for how we should be doing physics. And here it is, the machinery first principle. It sounds simple, but it's incredibly demanding. It says before you can claim you've explained something, you have to be able to show us the complete physical, cause and effect mechanism that produces it. No more placeholders, no more mysterious forces that are just a symbol in an equation. Show us the machine. If we actually adopted this principle, it would be a fundamental shift in physics. The main goal wouldn't just be to find a formula that fits the data anymore. The number one goal would be to uncover the actual, tangible processes that are driving the universe. The how and the why would have to come before the what. So what if the world of physics actually did this? What would happen? Well, the implications are frankly huge. It would mean we'd have to take a long, hard look at some of our most cherished theories. Any theory that's built on a concept without a clearly defined physical machine behind it would suddenly be considered incomplete, or maybe even on the wrong track entirely. And this final quote really drives home just how big of a challenge this is. The claim here is that this isn't about fixing one or two little theories. It's about a basic way of doing things that's been part of physics for a very long time, relying on the beauty of the math without always demanding a physical, mechanical explanation to go along with it. And that leaves us with this really fascinating and honestly, maybe a little unsettling final question. If we were to get really strict about this machinery first rule and force every single theory to show its work, to reveal all its inner workings, how much of our current picture of the universe would still be left standing? And what incredible new physics might we discover if we just started asking not only what, but how?